Hey guys, welcome back. We were dealing with solubility table in the previous class, and we have listed out all the solubilities in detail about acids and metal oxides, metal hydroxides, and carbonates in the third point. Next is sulfate. Then it is a chloride, phosphates, nitrates, etc. Okay. Right now, I'm going to take you to a very important topic today. Please be very careful about listening this and about understanding this topic, and that is called as salt preparation. Salt preparation. All right. Now the point is this, that what is salt preparation? That is how to prepare a salt. Okay. So there are how many methods? Three methods for this. Okay. And what is the method number one? It is called as titration. All right. Number two method is called as excessive reagent method. Excessive reagent method. Okay. And number three is ionic precipitation. Ionic precipitation. So right now we can see this thing, that this is called titration and this is called excessive reagent method and this is called as ionic precipitation. Done. Okay. So we have to look into the fact that which method should be used for which type of salts. Okay. Now number one is titration. Okay. I am going to tell you in a very to the point way so that you people may not get confused, because this is one of the topic in which I am observing that most of the students get confused if they will not pay attention. Okay. So please look at here. Number one is titration. It is used for all the salts of group number one and for ammonium family. All right. And for ammonium family only. Okay. Very, very clearly for the salts of group number one and ammonium family. For example, ammonium chloride, ammonium nitrate, etc. Okay. Then is the excessive reagent method. Excessive reagent method. All right. It will be used specifically for which type of salts? For salts, for all those salts, which are soluble, but are not part of group 1 and ammonium family. Group 1 or ammonium family. Okay. Number 3 is ionic precipitation. Ionic precipitation. All right. Now, ionic precipitation is only for insoluble salts. Only for insoluble salts. Okay. So these are the three methods, and when they will be used, that I have told you. Now we are going to make the practice for this, and in this way you people will understand the details. Right now I am going to take you to the topic of titration. Okay. Titration. What is titration? How we are going to perform that, etc. All details will be there. Okay. So number one thing you should know is this, that there is one apparatus which will be used in titration is called a burette. It is an apparatus which has a controlling tap at the end. How we are going to fill the partner in the burette? With the help of a filter funnel. Okay. So it means that we should know this thing, that there will be two partners, two reactants, two reagents which are going to react with each other in titration. Two partners. Okay. What are those two partners? Number one will be always an acid and number two will be an alkali. Okay. An alkali. So means one of the partner is an alkali and the other partner is an acid. All right. So these are the two partners, two reagents. What is an alkali? A water soluble base. Soluble means a water soluble, always soluble base. Okay. Now one of the partner will be taken into the burette and it is taken with the help of a filter funnel. Now the other partner is taken in conical flask. It is called conical flask. The other partner will be taken into the conical flask. With the help of which thing, with the help of which apparatus we are going to take it? With the help of a pipette, we are going to take it. Pipette is an apparatus which has a top mark, and it is called as 25 centimeter cube mostly, and it is used as a safety bulb, as a precautionary apparatus for this. Safety bulb is that red color thingy, that rubber thingy, rubber pipette filler, which will be attached with the pipette to fill the pipette so that the liquid may not go into the mouth of the student. Okay, this was the answer which I have told you when I was teaching you about apparatus. All right. So the conical flask partner, any of these two partners can be in conical flask, and the other partner will be automatically in the burette. Okay. If examiner is telling you to take a specific partner, for example, if examiner is saying you to take HCl is one of the acidic partner of the reaction, and you should take it into the burette, then you have to take it into the burette. All right. So one of the partner will be into the burette, whereas the other partner will be into the conical flask. The partner which is in the conical flask will be always like 25 centimeter cube. All right. 25 centimeter cube is why 25 centimeter cube? There can be a question, because it is a question, it is an amount, it is a volume which is going to give us a perfect result, a clear result, a readable result. Okay. A noticeable result. Otherwise, sometimes the volumes are so, if the volumes will be so less, so small in the quantity, then the results will not be very clear, you may say, or very accurate, you may say, or not very noticeable, you may say. Whereas if the volume will be in the larger amounts than this, then it is the wastage of the chemicals. Okay, so such type of the points must be in your mind. Okay. Now, along with the conical flask partner, which you have taken into the conical flask, there must be 2 to 3 drops of an indicator, which will be added with the dropper. Okay, it's a specific dropper, not very specific. I mean to say, sometimes the dropper has a calibration, sometimes it has marks on it, and sometimes it can be a simple glass dropper. Okay, it's a simple dropper which has a rubber knob at one end and can be a plastic or a soft plastic tube type of thing attached with that rubber knob, and sometimes a glass type of the tube through which the liquid can be shifted from the indicator bottle to the conical flask. Okay, so 2 to 3 drops of the 2 to 3 drops of the indicator will be added to the conical flask. Okay, now what is an indicator? Okay, let's move on to a new page. Indicator, it is a specific specific reagent, specific chemical, specific substance, or best name is reagent, which shows different colors in acidic and basic slash or the bracket alkaline mediums. Okay, and these are called as acid base indicators. Acid base indicators. Okay, details of acid base indicators, how they are reacting, what is happening, will be taught to you in A levels, but right now there is a small list of indicators, and unfortunately you people have to keep the colors of those indicators in your mind as well. Okay, now I am taking you okay, I can write here. Okay, so for example, the number one is universal indicator. Many of you already know this thing, that what is the color of this universal indicator in acid and a base. Okay, so for example, in acid we can say it is red in color. Okay, and the base, it is, you may say base or you may say alkali as well, because basically we are using it for the titration, and titration soluble base is used, so that is called blue. Okay, blue. Okay, so sometimes examiner can ask about the weak acid. If it is for the weak acid, then weak acid will give you pink color for this. Okay, and if it is for the weak base, then the color will be purple. Okay, so these are the situations which you people should know. Okay, now I am changing the board and I am taking you to the next indicator. Okay, this is now phenolphthalein, phenolphthalein, and it is in the acid, it is phenolphthalein, and it is generally called as phenolphthalein. Okay, so we are saying it, pronouncing it quickly, so that's why it is called as phenolphthalein, or the sound of phenolphthalein is there, but it is phenolphthalein. Okay, so in case of acid, it is giving you a colorless solution, I mean to say no color. And in case of a base, it is giving you a pink color. Okay, do we need to keep these colors in our mind? Yes, I'm telling you again. Number three is, this is number two. Number three is thymolphthalane. Thymolphthalane. Um, it is giving you, with acid, it is giving you a colorless solution, just like thymolphthalene and phenolphthalein, both are giving colorless, okay, with acid. Whereas with the base, it is going to give you a blue color. Okay, so this we have to keep in our mind. Okay, now I'm changing the board to the next, and that is number four, and this is called as methyl orange. Methyl orange. And what is the color? With acid, it is giving you a red color, and with base, it is going to give you a yellow color. Okay, it is going to give you a yellow color. Okay, so this is how we can say that we are going to notice these colors. Okay, guys, there is lots of information I would like to share with you people regarding titration. One more thing is this, that in titration, for example, there should be an acid and an alkali which are reacting alkali, and they are making salt along with water. Okay, one thing which you should know is this, that titration is based upon neutralization reaction, because an acid and an alkali are reacting with each other. They are canceling each other's effect, and the final compound is salt and water. Okay, now the point is this, that what about the solubility of the acid? It is soluble. It means that it should be water soluble, and all acids are water soluble. What about the alkali? It is soluble in water as well. Okay, it is soluble in water too. Okay, now what about the salt which is going to be produced, which is the product, which is the target actually? Okay, it is soluble in water as well. Okay, and it is with water, so we are not considering water soluble in water, but salt is dissolved in water, salt is part of water. Okay, so this is the basic target which we are going to take for titration method. Okay, one of the partner, that is either acid or an alkali, will be in the burette filled with the filter funnel, whereas the other partner solution will be taken into the conical flask. Remember, we are going to take a specific acid solution and specific alkali solution. Okay, so alkali is also dissolved in water and giving us a solution. We are going to take that, and we are going to fill the acidic solution in one of the apparatuses, either conical flask or the burette. Okay, now there is a trick about the indicator color. Okay, and what is the trick for indicator color? That is, you have to tell about end point. What is the end point? End point is a point at which the reaction between an acid and an alkali is basically completed. It is a point at which the reaction between an acid and an alkali is completed. And how we know this thing? When the indicator will change the color. Okay, indicator will change the color. Indicator will change the color. Okay, now the first point is this, that the first color is according to the flask, and the second color is according to the burette. Remember this thing, this is the trick which I am telling you, that the first color is according to the flask. For example, you are saying that first color about methyl orange, if you have taken an acid in the flask, what will be the color? It will be red. And if the burette has base, then what will be the color? The final color will be yellow. Okay, we are going to make the practice for this, inshallah. Thank you very much. Take care. See you all in the next